First off, thank you so much for coming. I know it's been a really long week, and I appreciate everybody coming out on a Thursday afternoon. So it's really excited to have you here. I'm really, really excited about what we're going to be talking today. So I'm with Ashley Nelson from General Mills. They have a fantastic story around Ansible that I'm really lucky to be here to share it with you. First question, I'm assuming everybody's here aware of Ansible. Who here actually runs Ansible? So almost everybody. How about in production? That's amazing, isn't it? So I think we all know why we're here. I hope you'll really get some exciting stuff out of today's session. And of course, if you have anything follow-ups or anything more, you'll come talk to us. So first off, who are we?
Hi, everyone. I'm Ashley Nelson at General Mills. I do DevOps work mostly on the Linux server side, but also a lot of server administration and storage and virtualization and just automation in general.
Awesome. Yeah, my name is Mike Dahlgren. I'm a cloud solution architect for Red Hat. And really what that means is I'm very lucky that I get to go and talk to a lot of different people and a lot of different customers and figure out what they're doing, what they're getting done. And really it's an opportunity to come back and kind of share that story and share that with other people to help solve real problems, but also opportunities to come here today. So what we're going to talk about today is a few things. What is on there?
Oh, yeah.
We lost a slide. Interesting.
Okay.
Excuse me? Don't know. We'll move on. So really what we're going to talk about is a couple different things today. First off is really Ashley's going to talk around like what automation looks like at General Mills, why they're here, what they're doing, really what that looks like from a perspective around how we got here. And then I'm going to talk around 3 different use cases around what they're doing in this space. And so this is actually kind of fun because her team really started the automation world. They kicked it off. They were the spear holders. But what happened from there is I actually went out and I surveyed around as she sent an email out to different departments in GM and found out that like 15 different groups are using it and 8 of them wanted to talk about it. Like it's phenomenal. So what we're going to do today is really just pick on a couple different use cases. First one's around operations. From there, we're going to talk about networking stories, kind of application development stories, and then finally, Ashley's going to come back and talk more about really like lessons learned. Like what would you do again if we could start from scratch? And so from there, I'll turn it over to her.
Okay.
And we can talk about that.
Yeah, thanks, Mike. So I'm going to go a little out of order here. I think we had some dual Google Doc editing weirdness. But first I'm going to talk about just our server patching process, and this is what prompted us to start looking into Ansible in the first place. Right around the time that Red Hat announced that they had purchased Ansible, we were halfway through a patching cycle, and we had been doing that manually this way that I'm about to explain. Basically, our whole team would get in a room together and divide up a list of servers in our environment, whether that be sandbox or dev or prod, whichever one we were patching at the time, and everyone would take a chunk of servers for themselves and manually run all of these stopping commands for the services that check and monitor and alert, and then would run the yum update command and then would issue a reboot on that server, and then would do that verification that the kernel actually updated after the fact. And that's all pretty easy for a person to do, but it's really time consuming when you have everybody on your team having to gather into a room to do these simple things. So we were about halfway through that process when the glibc ghost vulnerability came out. So that basically meant we had to go through and redo our patching, which was unfortunate because coordinating downtime is a significant pain, and glibc is used by pretty much everything, so you need to do a reboot after doing that patch. So Red Hat had issued that as a critical vulnerability, and we took that as the time to look into Ansible, something that would help us get through patching a lot more quickly. So what I did was I just did a yum install of the Ansible RPM, and it was really easy to just go ahead and get started. This is not an ideal playbook today. This was my very first playbook that I wrote in an attempt to solve our patching problem. But basically what that does is it has an assert statement that makes sure we're patching a server that we actually own. Don't want to go rogue. We have a script that updates the satellite channels that our server is pointing to. So we have it point to the newest base channel and child channels with all of the latest cloned packages. Then I just use the yum module that does a name equals star and upgrades all of those packages. And I have a notify reboot machine there. And what that does is it'll notify a handler, which is something that only executes if it notices that the state changed after executing that module. So the nice thing about this was if we did have a server that was updated already because maybe it was a new server, it wouldn't go through that whole process again. It would just not reboot if all of its packages were up to date. And if they were not all up to date, we have that reboot machine handler down there that would just do a shutdown -r now and reboot the server. And then we did have a separate verification playbook that we ran across the whole environment after the fact to make sure all the servers had been patched. Red Hat provided a command that let you do that. So basically, this is a bit dramatic, but 9 people in a cramped room executing all these manual commands got down to just 1 person being able to kick off this playbook and do a patch and reboot of all of our servers. And that was like an 89% labor savings in terms of the actual patching execution. We still have downtime arrangement, which has not been solved by Ansible. But in the future, we may just give users the ability to patch their own servers through Tower or something like that. So the second use case after we had all of that immense success with patching was to look at some of our other manual touch points, things that our team spent a lot of time working on, and that took us to server builds. And server builds are time consuming, especially now because we're seeing a lot of open source, like high performance clusters coming into our Linux environment. And before, when it was like 1 or 2 servers that a team needed, we could go through our process of like kicking off different scripts, and it was fine. It took about like 30 minutes per server, but as we were getting more and more of these clusters, that became pretty unmanageable. So someone on our team actually went through and fully automated. They took all of those scripts that we had in random places and wrote some additional automation within Ansible to just combine a complete pipeline for our server provisioning process. So this is a VM request form. This is our an actual segment of our request form in our environment that we made. It's not in Tower or anything. It's just a separate little web app. And basically what we do is fill in the details like host name, network it's going to be on, the virtual center it should be provisioned in, the Puppet environment that we want it to be a part of, and the version of RHEL, as well as dist list of who owns it and AD group that should have login access. So we input all the things into that request form. And what it does is actually goes through this series of Ansible roles. So the guy on our team separated all of the server build components into Ansible roles, and we have this master playbook that calls each of these roles. So the overall process is we create a VM, we set up the Pixie config for that VM, actually kickstart it, generate the Kerberos host key tab, and that allows us to authenticate users against the server using Kerberos. We then configure the Puppet client on that server and configure the Puppet server side, so sign those certificates and such, and then update the software on that server and reboot, much like that playbook I had shown you earlier, and then we install our backup software. So this is just an example of how we actually do that. Like I mentioned, we have all of these roles, and they reference this one config mapping file. So this file has a compute map, network, and kickstart that you see here, as well as Puppet environment. Basically every section of that Linux VM form is represented in this config map file. And then every single role that we use in our overall playbook will reference that variable file. So we know if we have a change to our environment, like a new network or vCenter, we just go to that one config mapping file and add that dictionary, and then it should work just as the rest of our automation does. So this is a play from that one playbook that does our server provisioning. As you see under vars files, we're referencing that config map file, and then under vars, we're just simplifying the reference of those dictionaries. So we don't have to say kickstart map, kickstart.kickstart profile every single time. But basically, those variables are populated by that form. So that form will give us an Ansible playbook command to run, and then that is what we like that playbook is right here. And then down at the very bottom, you see the Pixie config role. Physical server builds are also done in the same process. Basically, the only difference is we get the MAC address using the HP ILO module rather than using the VMware module. So this is just us getting that MAC address and then actually booting the server. And the rest of our provisioning process looks the same because Kickstart works pretty much the same across physicals and virtuals. So then the results of that is fully automated server provisioning, which is fantastic. And we can do all of those servers at the same time with just that one Ansible playbook command. It's 30 minutes of manual work time down to a minute of filling out that form and then copying and pasting the Ansible playbook command that it issues, as well as the inventory with variables we should use for those new servers. And then we just paste that into our Ansible server and press enter. And it's much easier now for us to automate for change. So if we have new vCenters or OS versions, networks and such, we just add them to that one place. So
Cool.
I'm going to pass this off to Mike, and he's going to talk about our second use case.
Hey, thanks, Ashley. So what's great about this is, like I said, Ashley and her team really started out the Ansible process, but a lot of the use cases we found inside of General Mills that were really simple problems. I shouldn't say simple problems. They're simple concepts, but they were a big problem. And so the networking use case really was exactly that. It was something that was causing me a huge pain in the butt, but it wasn't really kind of a straightforward problem that we can distill down pretty easily. So what this really looks like is the traffic going out from their data centers has to go through certain content gateways, obviously for security reasons and policy reasons and permission reasons, all the right reasons. The problem is certain cloud applications don't enjoy going through the content management system, or the content gateway. And it's specifically things like Skype and Office 365, and they really didn't appreciate the redirect, and it broke things in really bizarre and interesting ways. And so the challenge here is those applications actually have to have special routes to the intranet just for them. But because they're cloudified and they're cloud applications, it's not like I just whitelist a certain IP address. I have tens of thousands of IP4 and IPv6 ranges and IP addresses that have to be whitelisted for these applications to work correctly. And so what they did was, traditionally, was to go through and take this XML document that Microsoft would provide, and you can go online and download it, and take this thing and manually convert it over to ACLs and upload those to the edge router, and then have that be a process that would get this redirects correct. But this is like a 10-plus hour project that somebody has to do and sit there and copy and paste for the day, or for the days. And they said it's absolutely miserable. They don't wish that job on anybody. And because it was such a pain in the butt, it's something that did not happen as often as it probably should. And so the result from that was not an actual Ansible playbook, it was actually 2 Ansible playbooks. And the genius of this is the first one is real simple. It literally just checks to make sure that what they have running on their ACLs is the correct thing that should be there. Has Microsoft updated their access control list, or their redirects? If so, then run the second playbook. And that's actually manually kick off a second playbook. And what that does is a few different things. First off, it pulls this XML file from Microsoft. It runs a Python script to convert it out, pull out the different sections it needs per application. So then I get a file for Skype. I get a file for Office 365. Spit that over there, then use Ansible to deploy that through a template file to all the edge routers, and then go ahead and test to make sure everything's correct. So from the actual playbook, it sounds pretty hard, but it really wasn't that bad. And so if you look at the very beginning here at the top, the first thing they're doing is they're pulling down this XML file. They're running it through their own Python script that they did. And this is something they kind of developed on the side, but it really doesn't matter. The nice thing about this is we're getting the job done. But the Python script goes through there, finds the XML, picks the variables it needs, creates the appropriate template files. And it's not just a text file, it's actually a Jinja 2 template that Ansible can use. And why it's important that it's a template is because once I have this file defined, when I deploy it to the edge routers, it automatically gets configured correctly for each edge router. There's things that may have to get modified in that template as it gets deployed out. And so what we're doing is we're basically downloading this XML file, we're creating our correct template, and then we're deploying it out. And it's that simple. And so what it used to be literally a process that nobody wanted to do and took 10-plus hours, this thing runs in a few minutes. And they have the first job scheduled to run every week. Every week, test it. Do I need to do any more work? The second job, If I do need to make changes, run this job preferably in a maintenance window, so during the normal networking and policies. So what do they get? Like I said, removed a lot of work, but probably the bigger thing around this is not the amount of work that it took one person on the team. The biggest thing is it actually, when this runs, we know it is correct. Because before you have all these different files that you're editing and all these different access control lists, well, what if it's right 99%? Now you have like 100 video calls and one of them drops, right? Or your Office 365 isn't accessible one day of the year. Like just kind of weird, bizarre stuff. But you'd have to diagnose this, you'd have to find it and troubleshoot it. Well, it's nice to know like this part is correct, and we can verify it any chance we want. And then from the other part is like, it's something the networking team doesn't have to think about anymore. There's a lot of things you have to do in a day, and like this is a huge maintenance burden. No, like let's automate that, and we can move on and do something else. So it's a real fun story that like just in a couple days they've sat down, and almost the amount of time it took them to do the old process, they automated away the old process. And then it can go off and do something else. The extra use case I want to talk about is really around the app management team. And this one's really exciting to me because when you think about, like we love to talk about DevOps and all the things around it, but at General Mills they have developers, they have an operations team, but they kind of have something in between. And so they actually have an eApps or an application engineering team that is, they're not the operations people, they're not the coders, they're not the developers, but they're the team that has to maintain traditional applications from typically third parties, but they're the ones that are actually maintaining the applications. And so their job is basically to own the application from a runtime standpoint, but without developing it and without running the systems. So it's kind of an in-between space. But where their problem was, where their situation was, is there's like 11 people on that team, and it's really a case-by-case, hey, I need to deploy a new version of my app. I'm going to email a person. I'm going to make a phone call. Like it's a very manual process. But they're managing over 150 applications. And so it's a huge amount of time for these people just going back and forth, coordinating with the different groups, trying to figure out what they need to get done. And they had automation in place, but it's specific, and it's kind of interesting when you look at it. So they were responsible for just basic stuff, like not hard problems. Start, stop, deploy, reboot, the things you'd expect from an application team from a base level. But they were Windows focused. And the solution they built around Windows automation was kind of interesting, and I'll use that nicely, but they were using a SharePoint site, and they had a Word document in that SharePoint site that the end user would modify. And they had an actual process that'd be watching that Word document, and if it saw a modification, it would automatically spit out a JSON file, and then that JSON file would get run by a PowerShell command to make that change. It's interesting, like it worked, and I don't want to knock it because it definitely worked for them. But you can see like it probably wasn't the best tool for the job for everything. And what they found out is, they had this process down, but as things went on, they were traditionally a Windows team, but they got tasked with also managing all the Linux applications. And this is where that fell down because it doesn't work the same way. And so because of the Windows history, you could say, they also weren't automation people. These weren't automation experts. Really what you had is just a lot of people that were more operations. People emailed them, asked for a certain thing, do a certain action. That was the group that they're working with. But what they did? Well, you probably guessed it. It's another Ansible solution. But really, theirs all focused around Ansible Tower. And so they got in there, and essentially one person, Richard, really just took care of this. But a couple things first. Like they put everything in Git. That's a great start. Everything's version controlled. We want that. But what's really fascinating, what I love their story versus almost anyone else I've seen, is they did not create a script to do this thing. They didn't create a template to do this thing. They created a template of a template to do this thing. Does it make sense? So it's almost like, it seems a little bizarre, but it's not like I'm building a factory that builds cars. I'm building a factory that builds factories that build cars. Like they went one level higher. And so I've never seen anyone else do that, but it completely changed the way that they work. And we'll look at how this is in a second. And instead of using the SharePoint Word document, then they could also use the built-in Ansible Tower front end. And the side effect of this that was kind of unexpected is it also allows them to schedule operations. Before, you had to go in there, edit this document, and it ran when it caught the change. Now you can say, I want to do this upgrade on this application 3 o'clock on Tuesday. You get that out of the box. But what this looks like is kind of interesting. So the end user, you'd expect to run an Ansible job and have it work. But one level back, or 2 levels back, they actually started at the template. And so that has all the options that they could ever use. It has access to all the things. And then their automation team is not building Ansible scripts. What they're doing is they're taking that template and cutting it down to what that user would need. If that makes sense. Like they're cropping it down to just enough material, then they can provide that to the end user, and they have their self-service portal. The why this is cool is because this is all inside of one Ansible playbook, if that makes sense. And what you'll see from the operational side is the template has every field that you could imagine, every option, everything that you could possibly do, but you would never expose that out. What they found is, well, what they would do is their team would go through and customize it per application that came on board. So maybe I can auto-populate these fields. Maybe I don't need these options. Odds are they can only access certain servers because that's the only thing this application lives on. It's locked down to that area. And the end result of this is a very cut down form that they provide that to the application owners. And so the end user sees something like this. It's customized to them, it's specific to them, and they have control over their own destiny. And this is really cool stuff because it's everything you need, but it's really nothing you don't. From a playbook sample standpoint, I just took a couple examples from the master template, but this is what it looks like for them. So up here, it's just real basic stuff. Very top, we're stopping a Windows service. The next two are really around stopping a Windows application pool. But the template has all these built-in options, and their automation team would just go through there and crop out the ones they don't need. And anybody on the team could figure this out. What you also see when you look at this playbook is almost everything is variabilized. And that's important because it's part of one big master script. So what did this do for it? So they kind of got best of both worlds. Like the biggest advantage was it allowed them to make global changes in one place. So if they added a new infrastructure piece, a new firewall, new whatever, they go into one Ansible playbook and modify it, and it works across the board. But they still get all the job isolation and control and individual customization per user because the surveys are what's different, not the master template. On top of that, it allows this team of essentially like Windows operations people to easily build this out for new systems that come online, and even when they didn't know anything about Ansible. That's the amazing part. Like they were the exact corner case of what you would not expect. They did have a few challenges, and I do want to mention this, and I think this is probably where the real bread and butter of these kind of processes are, because nothing in this world is all easy. The biggest one that they found is with Ansible talking to all the Windows machines, you're going to need WinRM to connect in. But Ansible really wants to use HTTPS certificates that are signed correctly and set up correctly to do that securely. There isn't really a great way to do that from Ansible because Ansible needs to have that secure connection before it can do that thing, right? Like it's a chicken and egg problem. And so what they actually did, and there's not a good GPO object or a group policy object that allowed them to roll that out to their existing environment. If anybody does have a good solution for that, I would like to know what that is. But what they did instead was kind of a simple solution, but they just had a PowerShell script that they had run on each host. On part of the build process, that PowerShell script runs against it to make the final modifications to allow this to happen. But for their brownfield environment, they actually had to go back through and just run this one job that would enable Ansible Tower to be able to talk to these boxes. So not the end of the world, but it's something that they had to do. The bigger problem that they actually had is this kind of took off organically, and I think it grew faster than they expected. So originally, everything in their team was inside of one Ansible Tower organization, and at some point they said, we've gotten so much here, we're getting so big, we want to split off the middleware team and kind of split them off as another Ansible organization in Tower. And because it was so well built, it was already kind of tied in, that was a huge pain and a lot of effort to go through and manually touch these 100+ surveys and Ansible templates to pull them out somewhere else. So the real advice is it's hard to know how big and how big your scope will be, but before you install Tower or when you install Tower to do this, define all the organizations that from a company standpoint you think you want to need, and then add users to those organizations as needed. Because you can get away for 10 to 50 jobs, but once you get to hundreds and maybe thousands, it really gets to be a lot, and it's hard to pull that out after the fact. But the results of that, it's been incredible because it's not about just automating the thing, but it changed what that company and that department does. And so what they found is, it's not a bullet point on here, but they think they saved about 1.5 FTEs. But that's not the exciting part because it actually changed the role that department does in the organization. Technology does not cause company culture change, but having the wrong technology can hold it back. And so once they automated this away, and they found out they could cover 90% of the use cases automatically, it freed up the other 10 people to build out and do things that they've never done before. Before they were just the Windows team, now they're the Windows Linux team. Now they're looking at things that are well beyond the scope of what they started at, and their impact on the organization is much larger, even when they're doing it with less people. And so what they found was, the demand for IT services is almost unlimited, but we can only give a finite amount of services that are available to give. But once we raise that bar, you find out the bar is a lot higher than you thought it was. And so they've just become more and more valuable inside of General Mills, and it's actually changed what that group does. They're still called the eApps team, but their actual goal and their focus is actually different than it was even a year ago. So with that said, I'm going to turn it back over to Ashley, and she's going to talk about some general ideas and concepts around what she saw as she brought this in.
Thanks, Mike. So now that you've seen how Ansible's benefited a few teams in our organization, we're just going to talk to you about how we got more teams on board and how we helped set them up for success. So introducing teams to Ansible. The journey Ansible took at General Mills was we had brought it in on my team to help with a lot of our day-to-day operational needs. But then as we got more familiar with Ansible, we started talking to other teams, and they heard about how well it was working for us, and the interest just kind of gradually grew. And I shouldn't say gradually, it was pretty quick. And we started encouraging app owners and developers to write their own playbooks and handle their own kind of application deployment and configuration, because prior to that, my team has a Puppet environment that we would actually help them put their application deployment and configuration in, and then every time they'd want to change something in a config file, it would get overwritten by Puppet every 20 minutes, and they'd get frustrated and forget that stuff was even in Puppet. So it was nice to have that control kind of separated by the teams that actually are responsible for those certain things. And Ansible worked really well alongside Puppet, and as you saw, we used it to set up Puppet on our servers. So it fit well into our existing environment. So yeah, as more teams started reaching out to our team, we needed to think of a good way of getting them involved. And what we did to start was just meet with teams to go over the architecture of Ansible. I'd go and explain inventories and hosts and playbooks, just write a general playbook for them. And an approach I took sometimes was even write out some automation with them. If they came to me with a use case that they actually wanted to automate, for example, the Windows server team wanted to automate Jenkins upgrades, and they set up a meeting with me to just talk about the possibility of using Ansible to do that. And I was like, okay, what steps do you do? And we actually went through and wrote the entire automation right there in our meeting. So that showed just how powerful Ansible was and how quickly you could get to using it. So that was a good approach, and once you send them off with some automation that's relevant to them, they can quickly learn from that and create their own automation as well. Something else we did was get them started on core if we could. Ansible core is the one that just resides on the server. It's command line based, and if a team is more familiar with Linux, I recommend that one to them to start, just so they can figure out how it works, iterate more quickly. Like you can edit your playbook and just run the playbook right there, whereas with Tower, you would have to commit it and then push it to Git and then pull it down on Tower and run it. So it's just a lot more quick iterating if you do it on the command line. But if they're not familiar with that, then Tower is perfect for those teams because it allows them to use Ansible and also completely bypass Linux. So they could get an IDE that they're comfortable with, hook Git directly into that, push it, and pull it down on Tower. And that is how they do their testing. And when setting teams up with Tower, we would separate them by organization, which we found has typically worked well for us. But in the case of eApps, they were in a weird kind of hybrid team that eventually split out. So it was hard to accommodate that. But generally, it works to give teams their own organization in Tower that they're admins of, and then they control the playbooks that they push there and who they give access to run those playbooks. So as more teams started using Ansible at General Mills, we have a lot of common tools between our teams, and so therefore a lot of common automation was being done, a lot of duplicate work. So something that we're trying to do to solve that problem is open up repositories, have central repositories in General Mills that people can contribute our General Mills specific modules and roles to, and then use between teams. And we basically just enforce a master policy where people can only merge into master after getting approved by one person on our Ansible Center of Excellence that's very familiar with the best practices of Ansible. Something else that we do as part of this shared repository is have required and optional variables documented up front. Sometimes if you include a role, it's very hard to sift through and find all of the variables involved in executing that role. So that's something we were sure to call out in our role documentation. And then lastly, we just recommend people use this shared repository. They pull it down into their own, either using the Ansible Galaxy command line interface, which is something provided out of the box by Ansible. I think it's installed by default along with Ansible, but if it's not, you can Google Ansible Galaxy CLI, and it's available in the Red Hat repos. But that you just point to a repository that contains a role, and it will do the legwork to clone that down and put it in your project. Otherwise, you can just use Git submodules and clone them down periodically and manage the versions yourself. So we do have some challenges that we've used or run into with Ansible and Tower. The first one is more specific to Tower or Python dependencies. So if you've used Ansible, which it sounds like a lot of you have, you'll quickly find when using some more maybe vendor-specific modules that they rely on Python dependencies that are not installed by default when you install the Ansible RPM, which is fine. You can usually figure out how to do a pip install of that Python dependency. But when you have a lot of teams in Tower 3.1, that is, they are all sharing one underlying Python virtual environment. So there can be conflicts between teams. For example, we had a team want the latest version of PyWinRM, which is what they use to connect to Windows servers. And that broke the EAPS team's automation, which was not good. So we had to quickly find a solution for that. And what I did was just set them up in their own AWX container, which is the open source version of Ansible Tower that is the upstream to Tower. And that's been working well. We also had problems with using a jump host with Windows servers. So a jump host is something that's in the documentation for how you would use it with Linux servers that you maybe can't access directly, but with Windows servers, that kind of fell apart. Integration with TFS has been a problem. That's Microsoft's Team Foundation server, and that is what is hosting our Git solution at General Mills. And this is not really Ansible specific. It's a problem we've had just on all of our Linux servers using basic authentication when you also have Kerberos. And the solution for that has just been to create an F5 rule that only presents basic authentication as an option when you're doing a Git clone, only from the Ansible Tower servers. So it's not across our whole environment. And then lastly, job isolation. So job isolation is a good thing in Tower. It prevents people from being able to access and stomp on each other's projects and information. It's like the security layer between teams that are all executing automation on this one server. But that means that they have to be careful about where they write certain files because they can't go off writing something that they pulled from another server to localhost because that localhost is Tower. And you don't want to write over something else in temp or accidentally access someone's key tab. So Tower blocks you from pretty much all directories on the host. And the solution around that is just doing a delegate to when you're trying to write a file or access something you aren't allowed to on Tower. So the important thing to know is you're not alone when it comes to Ansible. Red Hat has support for Tower, Network, and Engine. And something our network team said was that it would have been helpful to have that support as they were getting started because they were banging their heads against the wall for a while. And it's difficult to help people with network-specific things when you aren't on the network team. Another thing that I really like to do is go to Ansible meetups in Minneapolis once a month. I'm sure they exist elsewhere as well. And Red Hat user groups we also have once every quarter. So I'm told there are over 100 of those, so be sure to look out and make sure you're going to the one in your community. So with that, we have a lot of future plans for Ansible. We plan to replace all of our isolated automation scripts with Ansible. So right now, our build process still has a lot of those isolated scripts, and if one of them does error out during a playbook run, it's hard to go in and debug that language. So it's helpful and more supportable if we try to convert that over to Ansible, and then we don't have to worry about languages becoming outdated. We just have to worry about keeping our playbooks from using deprecated things with each new Ansible version. We also want to eliminate manual infrastructure changes across the board. We don't want to have to log into servers and run manual one-off commands because that is cause for configuration drift and makes things more difficult to support and repeatedly deploy. So the dream is that all operations teams will be using something like Ansible or Ansible itself to effectively do infrastructure as code. We also plan to use the Tower isolated node feature. This is something that comes in Tower 3.2, and that would solve our problem of managing those Windows hosts in that environment that we can't access through the jump host. So Tower, that isolated node, would essentially be that jump host now. And then lastly, with Tower 3.2, it also solves our Python dependency problem. You can have separate ones for each team. So whenever a team needs a conflicting Python dependency, we'll just duplicate that standard virtual environment and then install the one specific to their team's need. So with that, thank you everyone for coming, and Mike has some words as well.
Yeah, I just want to thank General Mills for coming. I really appreciate that. Like I said, we heard about like Richard's team and Warren's team, like talking about their use cases, but it's really been great to see what Ashley's been here to do and help spearhead this with her team about making the company-wide changes with just as something as simple as a technology. With that said, a lot of people take pictures of the slides. They're all available online. The PDFs are up there, including the 3 or 4 that got eaten in the cloud. So sorry about that. Well, thanks again, everyone. Like I said, I appreciate you taking your time out of the day. And thanks, Ashley and General Mills.